So surface engineering, it is a subtopic in the module 5. So it covers again one question, complete question. And the surface engineering, it's an important topic. We already know that in the first introduction class, tribology means it is a combination of many subjects or many uh, branches which involves combinedly called as a tribology. In that, material science is the one, mechanical, mathematics, physics, chemistry. Okay. At the same time, we need a surface engineering or surface topology or surface. A study of surface is an important subject or a concept. Again, it is a part of a tribology. So, whatever the tribological solution, it is also a contribute to the tribological solution. This surface engineering also contributing to a tribological solution. And what is this surface engineering? What do you understand from the tribology? Surface engineering. Can you give a simple example? Surface engineering or surface? Yes. Yes. Come on, tell me. Surface. Take an example on the road. Okay. Okay. There is a difference between this tiles road and the rough road. Okay. So on which you are moving fast, whether in the rough road or very smooth road like tiles. Hmm, tiles. Can you able to move faster in tiles? Tiles are rough road. Rough road because that rough road provides the friction. With the help of friction only you can able to walk. If it is a very smooth surface, a glassy surface or a slippery surface, then it's not possible to walk because it completely reduces the friction. So that is what the surface difference, a rough surface and the smooth surface. If you make a very smooth and fine glassy surface, then it will try to reduce the friction. Of course, that is what we want in the machine components, correct? But not for the walking purpose or for the driving purpose. Okay. So in the driving and walking purpose, we need some sort of friction, some sort of rough surface. Then only we can do our daily activities. Okay. But in the come to the components, again that surface is directly depends on the load carrying capacity, on the other factors like life of the component. That surface will decide the life of the component. If it is a smooth surface, okay, a fine surface, if it is reduce the friction, obviously increase the life of the component, correct? So that's why this surface engineering is directly depends or directly contributing to the life or tribological solution of the component. Okay. So this is a surface engineering scope. Means why we have to study this surface engineering? What is its importance? Briefly, I explained. See, first in the first block, the failure of an engineering component occurs when its surface cannot adequately withstand the external surface force or environmental to which it is subjected. Means what does it means? In any engineering components, it is a failure occurs. Okay, ultimately after certain life cycle there is a failure occurs, correct? That failure, it is also one contributing factor is surface. Okay, if the surface is not able to sustain the load, if the surface is not able to sustain the load, then directly the failure of the component. Or if the surface is subjected to environmental conditions like moisture, rust, okay, again there is a failure in the component. So that surface is a one important factor. It also contribute to the failure of the component. Okay. Next, external force can be, and those external force can be thermal force, okay, can be optical forces, can be magnetic forces, or can be electrical or wear or corrosion. These are all which are contributing to the surface of the component, because the thermal temperature is first enter into the surface, then penetrating to the interior. Correct? First it will enter to the surface, then it will disappear into the where, or dissipating to the depth. Correct? Is it correct? So first the thermal loads, optical loads or magnetic, whatever the magnetic force or whatever the electric force, which are first come into contact with the surface, then it will penetrating into the component. So first always this or where is occurs at the surface only, not at the depth, not at the inside. Always where occurs at the surface of the component, or corrosion is also occurs at the surface of the component first. Is it correct? So for these forces, the surface is an important criteria. Okay. So these forces can directly act into the surface. Next, sometimes a technological progress and manufacturing efficiency requires surface modification. Yes, this is another important. A technological progress or a manufacturing efficiency. So manufacturing efficiency means grinding. So take an example of grinding or a simple lathe. So in the lathe you are performing a turning operation. Okay. So first you perform turning to reduce the thickness. After that what you are doing? Finish turning. In the sim lab you are doing now first turning. After turning again finish turning. So in the finish turning what happens? The rate of material removal is less, but it provides the smooth, a fine finish. Correct? In the same way, if you go with the awning or if you go with the grinding or awning, what happens? The wear rate is very less, but it will provide the very smooth surface, a fine surface. It will increase the efficiency. Some of the components need a very fine finish, it need a very accurate finish, then it will increase its efficiency. Instead of that fine finish, if you provide the rough surface, again there is a failure in the component. Okay, for that purpose, this surface modification is a must. So modification may be it may be chemical or it may be mechanical, whatever it may be, either by disturbing the surface or modifying the surface or without any changes in the surface. Example, coatings, just like a painting. So what we are doing in the painting? We just apply the paint on the wall without any modification in the wall, just applying the paint. It's a one type of coating. Correct? So another type means first you are chipping on the wall surface, then you are applying paint. It is another method. Okay? Means we are going to change the surface, then apply the paint. It's a one process. Without changing any surface, just simply applying the coat. It's another. Okay? Like this, there are so many methods that will help to modify the surface to just to improve the efficiency. Clear? So next, by doing all this, what are its economical aspects? By doing this, by applying the coatings, okay, in the UK. So in UK, approximately in 2005, there is a one report published. By using this coating method, they can approximately save nearly more than 20 lakhs. At that time, okay, in a one industry, by applying this coating, okay, with the help of coating, okay, they save more than 20.9 lakhs nearly. Okay, so that much of saving is occurs. So it is become a more economical in the aspect of economy. It is also advantage. Okay, and finally this surface properties having the most powerful function. Okay, this whatever we are doing the surface modification, it's a more powerful uh, function which helps to modify or create or modifying new or existing coating methods. That is what we are going to discuss in the further of this chapter. Clear? So this is what the scope of surface engineering. So surface engineering, it is a contributing to the failure. Okay, and what are the factors which affects? That is thermal. These are the external forces. Okay, and these forces directly affect the technologies, and by applying this surface we can increase the efficiency. Okay, and by doing all this we can save a lot of money, or it is become very economical. And these things we are briefly discussing further proceeding of this chapter. Yes, this is what the surface engineering. This surface engineering refers to the alteration. This is surface engineering or surface treatment. It is also called as the surface treatment or surface engineering, which means it refers to the alteration made to the surface. Only alteration made to the surface. Just like a mobile. On the mobile, you are going to use the mobile cover. Is it apply marker use marker mobile cover? What is the purpose of mobile cover? If you won't use mobile cover, what happens? It will. What happens? If you not, yes, it will damage the display. Just to protect the display, you are going to apply one cover. Okay, that cover will protect from the cracks, from the moisture, from the water, whatever it may be. It will protect the display. Same thing, the entire that mobile is just like a base material. That base material is protected by this coating. Okay, surface. That surface is applied by some sort of coatings. That coating will protect the material. If the coating is wear out, again we can do the another coating. Okay, if the entire component is wear out, what happens? We have to replace the entire component. It may become not economical, it may become costly. Okay, the surface engineering refers to the alterations made to the surface to engineering component with an intention to achieve improvement in properties. Just so, what is the main purpose of this applying coatings or altering the surface means? Just to achieve the some of the properties, just to enhance the some of the properties, like first is hardness. If the more hardness, it will increase the load carrying capacity of the component. That is what we already discussed in the bearing materials. If the more hardness material, it will increase the load carrying capacity of the bearing. Okay. Next, it is also increase the wear resistance, high temperature resistance, corrosion resistance. Okay, and these are all making a significant characteristics to build a structure. Okay, so why we have to use the surface engineering means just to enhance the properties or a very important properties, desirable properties. Okay, so a properties na increase madake, just to enhance madake, we are going with this surface engineering. And this surface engineering is a combination of, it may be, okay, say friction and wear control. By using surface engineering, we can control the friction. Is it correct? Is it correct? By using the surface engineering, we can make a surface that surface will produce a very less friction. If you provide a very slippery, provide a very smooth surface, then it is become a very frictionless. Okay, just take an example in your gym. Okay, so there is a bar. Okay, along with the bar there is a weights. Okay, that shaft, on that shaft, for holding purpose, they will make a some knurling on the shaft. What is that purpose? If there is no knurling, what happens? Yes, it will slip. The smooth surface will slip easily, but knurling surface won't slip. Just to provide a proper grip, they make a knurling. Correct? The same thing here. If we make a very smooth surface, very fine surface, obviously it will reduce the friction. If it is a rough surface, then it produces the friction. So it is always on the surface. Knurling only made on the surface. Shaft in inside only on the surface. Yes. Here the surface engineering very important factor. By using that, we can reduce the friction. If you reduce the friction, indirectly it will reduce the wear. Where there is a friction, there is a wear. If reduce the friction, indirectly reduce the wear. Next, corrosion resistance. We can make our component as a corrosion resistance by coating a proper material. That material is corrosion resistant material. If it is a steel, it is exposed to the moisture, easily get corroded. Correct? That steel is coated by some sort of material. Okay, aluminum alloys, whatever the corrosion resistant material. What happens? Then it will reduce the corrosion on the steel. Means it will increase the corrosion resistance property. Okay, and thermal protection. It provides the thermal protections. Okay, and in other cases, electronics. These are all used in the electronics purpose or computer science to storage. Okay, for the sensors we are using. But our main intention is just to reduce the friction, corrosion resistance. And this is what some of the examples of surface. You can see this is a surface, and these two pictures, okay, it is seen by SEM, scanning electron microscopy. Okay, it's a surface. See how the surface is there. Actually, it is look like a very smooth surface by naked eye. If you see from the microscope or if you see from the scanning electron microscopy, it will look like this. Again, there is a waviness. Again, there is a roughness. Even though by naked eye it's very smooth, but if you see from the microscope, it will shows the waviness in terms of microns. So next is what are the benefits by using this surface engineering? What are the benefits and why we have to use this surface engineering? Okay, surface engineering, there is a some sort of another process are there, but totally if the surface engineering we use in our component, what happens? What are its benefits? Okay, first, a specific properties. So these are the some specific properties. I told this surface engineering used to increase the increase the what, or enhance the properties of the material. Correct? The surface engineering used to increase or enhance the properties of the material. Okay, so these are the some specific properties. That is what we already discussed: wear, friction, corrosion, fatigue, reflective, emissive, color, thermal, electrical conductivity. Okay, so these are all some sort of properties, and these properties can increased by using surface surface treatment or surface engineering. Both are same: surface treatment or surface engineering. Okay, so benefits. Benefit means advantages. What are the advantages? So first advantage is it will increase the life of the component. It will extend the component life. Correct? Is it correct? Can you agree with this statement? We can use we can use the surface treatment directly. It will affect the component life. Is it correct? How? How? How it will improve or extend the component life? That is by reducing the friction. If friction reduces, indirectly wear reduces. If wear reduces means yes, life is increases. That is the first advantage. Next, improve the resistance, wear resistance. It will improve the corrosion resistance. Okay, that surface improves the properties like wear resistance, corrosion resistance, satisfies the customer's needs better and lower component. Okay, so if it is increase the life, then automatically it is become economical. If it is economical, then it will satisfy the customer needs. Correct? And it is become a very economical. Is it correct? Then reduce the maintenance. Maintenance it will reduce, because friction reduces means indirectly maintenance also reduces. If more friction is there, then time to time you have to introduce the lubricant, you have to provide the proper lubrications, you have to see the surface, and you have to every time you have to monitor. It need a more maintenance, but here by using this we can reduce the maintenance. That is what increase the reliability. It will increase the reliability and reduce the cost, and of course reduce the emission and environmental waste. If it is a it's a surface is waviness or a rough surface, then there is a friction, and that friction will cause us. What happens if the friction is there? It will increase the temperature. Once the temperature increases, it is directly contact with the lubricant, and that lubricant with a high temperature may produce the any sort of gases, correct, or toxic gases. So that will control by using this proper surface treatment, and also improves the electric conductivity and increase the appearance. The aesthetic look of the component is increases, correct. Can you agree with this? The aesthetic look of the component is increases. Just to take an example of normal turning and after finish turning. So in the finish turning and normal turning, so which component looks very fine and appears very good? Hmm? Finish turning. Okay, the finish turning and compare with the grinding. So which one is provides a better aesthetic look? I will perform the grinding operation or honing operation. Okay. So what happens? It will increase the aesthetic. Means the surface finish will become very fine, and it will look like a very aesthetic look, very good aesthetic look. Or can a mirror? If it is a mirror finish, it will appears very fine. If it is a rough, ಯಾವ ಥರ ಇರುತ್ತೆ? See, ಇಲ್ಲೇ ಇದೆ ನೋಡಿ. So in your plywood, okay. So this is a very fine finish. ಯಾವ ಥರ ಕಾಣುತ್ತೆ? It looks very fine. Okay, aesthetic look is good. But ಈ ಸೈಡ್ ಇದೆ, ಬ್ಯಾಕ್ ಸೈಡ್. ಸೊ ಅಲ್ಲಿ ರಫ್ ಸರ್ಫೇಸ್ ಇದೆ. Okay, so ನೋಡಕ್ಕೆ ಹೆಂಗೆ ಕಾಣುತ್ತೆ ಅದು? See, so if it is a very fine surface, the aesthetic look appearance is increases. Okay. So these are the some important properties, okay, by enhancing, or these are the some benefits what we can expect from using surface treatment or surface engineering. By improving durability, it reduces the wastage of natural resource and energy. Obviously, if the friction reduces, the power consumption also reduces. If the power consumption reduces, power generation is also reduces. If the power generation means again from the thermal or from the so from the thermal only, from the coal only we get the power. Okay, so that natural utilization of natural resource will reduce. Obviously, it will save a lot of energy. That energy saves the natural resources. Yeah. So this whatever the benefits is tribological solution, the same benefits is also from the surface and surface engineering, the automotive parts. If you use this surface engineering in the automotive parts like this, see, you can say automotive parts, gates, okay, in inside the combustion chamber. So inside the combustion chamber, we are going to put the some materials just to increase the efficiency. Okay. So here also we can minimize the power consumption or minimize the whatever the fuel consumption. If the fuel consumption is reduces, what happens? The efficiency increases, and for 1 liter, if you get a 50 kilometer, it will increase by 70 to 80 kilometers. Okay. So this is for the advantage if you use this surface engineering in the automobiles. So these are the components you can see. These are the cutting components, forming components, okay, decorative. So your rings or watch, okay, whatever the bracelet. For that also we are doing this coating. And automotive parts, biomedical parts. Biomedical means scissor, okay, knife, some sort of holding. So these are all biomedicals. Here also we are going with the surface engineering. Surface engineering means altering the surface. Okay, now come to the a proper definition. So definition. What is meant by surface engineering? Surface engineering means it is make changes to the surface of the material. Only surface of the material. not in depth. Only the surface we are going to change. That is what the surface engineering or surface treatment. Surface treatment or surface engineering means to make change to the surface of the material. Okay. Next, what its purpose? Okay, definition is over. Just to make the change on the surface. Next, what is the purpose? Why you have to do this? Yes, to increase the properties, to gain or improve the surface. Okay, surface, or to improve the components performance and service life or aesthetic or economics. Okay, so this is what we are improving by using surface treatment or surface engineering. And surface engineering process is named marketing. How? So there is some process are there. There are many processes for modifying the surface properties. There are important three categories of surface modification. We are just modify the surface. That is called surface engineering or surface treatment. How we are done means with the help of three important processes. There are a lot of processes are there, but here there are three important categories. See, surface coating and surface modification. So here the surface here a layer of different materials is added to the surface. Coating means a layer of different material. This is what the base material, okay, primary material, and here there is a layer of other material which is coated or deposited on the base material. Substrate on the curriculum, we can call it as a substrate. Here surface composition and or microstructure is modified. Whatever the surface is there, this surface we are going to modify. This composition is we are going to modify. We are not coating anything, but instead of coating, we are modifying this surface or this composition. Okay, that is another. So this is what the microstructure. Surface engineering process. There are three categories. I told three categories. The first important category, surface modification. All are surface modification. Surface engineering means altering or modifying the surface. Clear? So the ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ with the different categories like first one, surface modification without changing the material chemically. We are not going to change the material. Chemically it is same, remains the same, but we are going to change the or modify the surface. ಅದು ಹೇಗೆ ಅಂದ್ರೆ the changes made by thermal or mechanical means, altering metallurgical or surface texture or grains. Clear? That is what we are going to change. That we will discuss. Next, surface modification. Second category, surface modification by altering surface chemistry, by changing the surface chemistry. Okay, here without changing the surface chemistry, here changing the surface chemistry. These process involves diffusion or new element into the surface of the material. The original substrate material constituents play an active part in the modified surface. Only the surface we are going to change. And the third one, it's a common one. It is surface modification by adding new material onto the surface. It is also called as coating. Okay, coating means on that substrate we are going to deposit on the other material, layer by layer. It is called coating. These processes essentially add a new material. Here we are going to add the new material to the surface as a coating and do not involve any substrate material constituent to the surface. Okay, substrate means it's a base material. There is no contribution to the base material. Base material is independent. Only thing is that layer will contribute to the action. Clear? That is what coating. These are the three categories. First one is without changing the surface chemistry. Second one is with changing the chemistry. Third one is we are adding new material. That is what coating. Okay. So here, first one, surface modification without changing material chemically. So chemically that material remains same. So what are its process means? The first process is thermal process. First process is thermal process, the surface heat treatment. We are applying heat treatment to the surface. Only surface we are going to change the heat. Okay, heat treatment. Particularly those that undergo phase transformations like, so in the phase transformation, you see in the steel, okay, aesthetic, there are different phases. ಯಾವ phase ಬರುತ್ತೆ? Cementite, okay, next anthracite, different types of phases. The phase changes with respect to the temperature change. Okay, the phase will reform with the help of temperature. The same concept here. Okay, you can take an example of steel or cast iron. If you increase the temperature, it will change the phases, and that is done with the help of laser, flame, or induction. Okay, with the help of current, or with the help of flame, or with the help of laser, we are going to change the surface temperature. That is what thermal process. Next process, mechanical process, a cold working process, or surface spinning, or a short blasting. I think already studied these things. Short blasting, okay, and explosive. On the surface we are going to explode. Okay, by exploding or short blasting, it will change the temperature. Okay, mechanically we change the temperature. So by using this changing surface structure and using machining and blasting, these surface structure we can change with the help of machining process or by the blasting. By blasting or machining, we can increase the temperature, and the temperature on the surface will change the texture. And other process, it may be chemically or electro or etching, laser engraving. Have you heard these words? Chemical or electro etching. Okay, with the help of current we are going to change or modify the surface. Okay, so these are all another methods. Ultrasonic cleaning process. Okay, so these are all another process. Next is surface modification by changing the surface, and again this is a thermal based. First is thermochemical diffusion process. Here carburizing, have you heard carburizing? There are different types of heat treatment, hardening, okay, nitriding. In your material science you studied already these things. Okay, carburizing means increase the carbon percentage. Just to increase the carbon percentage, it is called as carburizing. Okay, carbon nitriding means increase the carbon and nitrate percentage. If you increase the carbon and nitrate percentage, it will increase the R's indirectly. Okay, so these are all different types of heat treatments. And the rest is aluminizing, chromonizing. Okay, so means increasing the chromium, aluminum, silicon percentage. And electrochemical process, chemical conversion, coating, and ion implementation process. So these are all some process which we are using to change the surface chemistry. Clear? So these are the some examples. And coating, so this is what the surface modification last category, that is what coating. The coating may be a welding type, a thermal spraying, okay, just like a painting, thermal spraying, electroplating, electrolysis, okay, galvanizing, or PVD, a physical vapor deposition, CVD, chemical vapor deposition, a painting, a powder coating, and cladding. So these are all different type of examples or process which for using for coating purpose, just to change the surface. That is what modifying the surface or changing the surface is called surface engineering. And in the next class we will discuss some important types of process. Okay, the important process now we will discuss.